Have you ever pondered why a book on your table doesn't spontaneously slide off, or why a rolling ball eventually comes to a stop? Today, we delve into the fascinating world of physics to answer these questions, exploring the fundamental concepts of rest and motion. Picture a book on your table. It stays exactly where you placed it. It doesn't change its position with respect to its surroundings. This, my friends, is what we call rest. Now imagine pushing that book gently. It slides across the table, changing its position. This illustrates the concept of motion. Now let's add a layer of complexity. Motion is not a one-size-fits-all concept. It can be broadly classified into two categories: linear and rotational motion. Linear motion is exactly what it sounds like. It's when an object moves in a straight line. Think of a car driving down a highway, a football sailing through the air, or someone running. The distance these objects travel is called displacement, and the rate at which they change their position is their velocity. Rotational motion, on the other hand, is when an object moves in a circular path. Picture a ceiling fan spinning or a wheel turning on an axis. The distance these objects travel in a circle is their circumference, and their rate of rotation is their angular velocity. But physics doesn't stop there. We also encounter periodic motion, where an object repeats its movement over and over again, like a pendulum swinging back and forth. And then there's random motion, where an object moves unpredictably, like particles floating in a liquid. This vast field of study, examining the relationship between motion, force, and energy, is known as mechanics. And it's not just for the classroom. Motion is everywhere around us. Planets revolving around the sun, waves crashing on the shore, cars driving on the road, airplanes soaring in the sky, birds gliding through the air. All these are examples of motion in our everyday lives. So, to summarize, the concepts of rest and motion are fundamental in physics. Rest is when an object maintains its position relative to its surroundings, and motion is when it changes its position. Motion can be linear or rotational and can even be periodic or random. The study of these phenomena, known as mechanics, plays a crucial role in understanding the world around us. So next time you see a ball rolling or a bird flying, take a moment to appreciate the physics at play. Who knew that something as simple as a book sitting on a table or a ball rolling across a field could be so fascinating? That's the beauty of physics. It turns the ordinary into the extraordinary. And remember, the world around you is in constant motion, even when you're at rest. Now, let's take a detour and explore a fascinating intersection of physics and technology: the AI bodies. These are artificial intelligence systems that interact with the physical world, much like humans or any other objects subject to the laws of physics. AI bodies use sensors and actuators to perceive and manipulate their environment, embodying the principles of rest, motion, and mechanics we've discussed so far. They are becoming increasingly prevalent in a variety of fields, from autonomous vehicles and robotics to virtual reality and gaming. As we continue to advance in technology, AI bodies will play a significant role, further blurring the lines between the physical and digital worlds. So, next time you see an AI body in action, remember the physics behind its movements and interactions. It's another example of how physics turns the ordinary into the extraordinary.